And hello from Sydney. Welcome to the Proof of Concept podcast, the tech show where we explore real life use cases from the field and discuss some hot questions in the field of data science and AI. I am your host here, Grant Case. And today we are joined by Rishu Saxena. So I have known Rishu for almost 2 years now. Rishu is currently at Snowflake, where he works in the CTO office, working with organizations and their use of data science and AI in the cloud. Today's topic is really about why is it great to be a data scientist in the cloud? But before we start, Rishu, welcome to the Proof of Concept podcast.
Jan, thank you so much for the introduction. Hey, by the way, I think it's more than 2 years. It's more than 3 years. Yeah, we met when you came first to Sydney, I think back in 2019.
Yeah, so a little further than that. So imagine when the pandemic comes through, time has no meaning anymore.
I totally agree with that.
Yeah. So I was saying that today's topic is really why it's a great time to be a data scientist in the cloud, but that also kind of starts with the Proof of Concept podcast. I'll deviate a little bit. Why is it not a great time to be a data scientist not in the cloud?
Yeah, look, I think it's a very good question. To be honest, data scientists today, and I speak to a few organizations, they are not. So the few good things have happened in last, I would say, 20 odd years. As you know, data scientists, they use libraries and they love processing large volumes of data. And we have had technologies from last almost 15, 20 years that are more accessible to data scientists to actually benefit from the fact that they can get access to the compute and that they can use this data. Because if you look at the libraries, like things like PyTorch, which is built on top of our existing libraries, all these were built ages ago. Then nothing that new has happened in last 15 years. What has changed is the fact that you can now start using these libraries at scale. If I remember the first driverless autonomous car was back in early 1990s. It is nothing new that we have done in last 10 years. Like Tesla is not just suddenly came out of the box and suddenly invented something new.
Well, I don't know if Elon Musk would agree with you on that one, but yes.
Oh, yeah, sure. But all I'm saying here is that the fact that it is more commercialized is because there's all this compute and storage that is available abundantly in cloud. Now, on the flip side, the question was, if you're not in cloud, you're still living in an era where you're restricted by how much data you can access, how much compute do you have access to. And for that matter, like the data itself that is required to do any kind of machine learning, you are again constrained by the fact that that data is not coming in the data platform that you're using for data science workload. That they're all going into, they're ETLing into a data platform that, where business users, analysts, BI reports take priority over data science. And it's a sad reality, right? And then data scientists are asked to take a copy of this data into another fixed environment. And it's a standard problem that I'm glad that more organizations are actually coming out of this problem. They're not constrained, but there's still quite a lot that are dealing.
And I think that's, you've kind of hit at the ground running for us in the Proof of Concept podcast. It's like, what is so cool about this particular technology? You really kind of hit it on the head. I always, when people ask, well, all this machine learning stuff seems to be brand new. It's like, no, it's not. K-means clustering, that algorithm was like 1956. Yes. So SPSS and SAS have been around for 30, 40 plus years. So it's not as if this stuff is new. It's just, we now have so much more compute and storage in order to tackle these problems. So what else is so great? I mean, we talk about being a data scientist today, working in a world of cloud.
Absolutely. So there are two parts to this thought process. First of all, being a data scientist itself, right? It is, I would say, last 5 years, 10 years, like everybody can get access to content, resources, books, material that they can actually go and educate themselves on this topic. I remember back in 2012, when I was coming out of data warehousing, getting into big data. And for me, like this fact that you can just predict the weather tomorrow, like I just could not understand like how that is happening. And to
Mhm.
be honest, it was very, very hard for me to then wrap my head around like what is it that we are using under the covers to make this happen. And now when somebody asks me like, hey, how do I get into data science field, I'm like, mate, you have 1,000 resources. Like there are
Yeah.
courses available. You
Mhm.
can educate yourself. There are libraries. Like all you have to do is call a library, call a function, one single line of code,
Yeah.
and you have built a model. I'm like, that is amazing. Right?
Yeah.
So that's yeah. Sorry, go ahead.
Yeah, no, I tell this story in 2014. I was working with an organization in the United States called SiriusXM, and they were attempting to develop a new algorithm to predict what are the next three songs to listen to. And when you're talking about when you're talking about music, you have both rules, so you can't play the same artist so many times in the same hour, but you also want to be like, here are the people who want to listen to. This was going to be a significant amount of effort and intensity and money and lots of people to actually put this up. 2.5 years later, 3 years later, I was sitting in a meetup where people had been taking Spotify data and doing the exact same thing we were doing there. And it was like,
Yeah,
a couple of folks in a data science program. So I think that kind of tells you a little bit about the speed at which things are moving and why it's so incredible. But I guess my question, because of your role at Snowflake in the CTO office, you're attempting to discuss a lot of times and help people understand what this could be for their organization. So, and we talk about Eli Five, my CEO. So Eli Five, the CEO that you're speaking to, especially customers that are typically looking at Snowflake, they're lower end on their maturity. They're just getting it started in the cloud, and a lot of times, how do you explain why this is such an important segment right now?
sure. Also, we did not cover the second part of the previous question, but I
Oh,
think
I
the
am
answer for
sorry.
this, no, no, all good. But the answer for this and the other one actually are kind of overlapping. Um, in cloud, all of us know like there's practically unlimited storage and unlimited compute available, right? How do you make use of that? That is the biggest question today. Like infrastructure is not a problem. Nobody's going out there and saying, hey, I'm going to invest like $25,000. I'm going to get this massive machine that has, I don't know, 64 cores and, I don't know, 20 terabytes of RAM in there, right? That is not what people are thinking about today. They're thinking about, hey, this server is available for a couple of dollars an hour and
Yeah,
I can use this server. The sad part of how most organizations are still going into cloud and running their data science workload is they're converting what they have on prem into what's available in cloud. So
yeah,
they end up signing large contracts. They end up building these massive machines, ecosystems. So they've instead of just to the point, instead of buying a server, now they're renting a server, but then they're acting in exactly the same way.
mm, mm.
And and
They're
this is where
lifting and shifting. They're not reimagining.
no, no, absolutely not. And this is where I think Snowflake is coming in and it's actually talking to the customers. And there's a lot that we are doing here, right? So we have to, of course, have to have ways of running or supporting ML engineers, data scientists to natively run, their Python code. They're accessing their open source libraries. I think the bigger point here is how can we make sure that access to compute is monetized to a point where they only pay for what they want to use for. They
Mhm.
get access to as much compute as possible, first of all, right? So if they want to run a training job on a terabyte of data, which back in the days was not even imaginable, but today, you can do it. But taking this example, right? What are organizations doing today? They're beefing up a 4 terabyte machine. At the max, they can run like 4 projects in parallel because they have now paid for this massive infrastructure resources on cloud itself. With Snowflake, what we are telling them is, hey, you want to do this, you want to train this, you only want to train this once a week or maybe once a day, right?
Mhm.
Or you want to run continuous training. There are 3 patterns there. Um, Only pay for a number of seconds you're going to go and train your model. And once the model is trained, just throw away that machine. You
Mhm.
do not need that machine. You don't need to pay for that machine. And now
Mhm.
you're no longer constrained with with the amount of resources and how quickly you can get access to those resources. So you
I
can
think that would
innovate
be something, in your conversations, I would say that is, how does that resonate with a CIO or a CTO or a chief analytics officer? Because I think that would be an incredibly compelling argument for them, right?
Absolutely. C-level execs, they so if they know what they're doing in cloud, and this is not the first time they're having a conversation. And the reason I bring that point is because a lot of times when they are making the first move to cloud, they're very worried about the cost factor and everything, right? So
Mm.
because I can access this massive machine with terabyte of RAM, I might just spend too much money. And again, there are these safeguards and there are things that Snowflake has built, and it has actually recognized that as a problem, right? We always had those safeguards. We have now actually improved on them. We have
Yeah.
put in place.
Well, I think that's key for all consumption based tooling, whether we've
Absolutely.
seen in AWS or Azure, GCP. Nobody likes to, when we're moving from the ground to cloud, there was a fixed cost. I was in for that 50K on that server, and I'm not going to spend any more. I'm going to have to pay for the power going into it and the people to upkeep, but it's not going to show up one day and have a $250,000 bill associated with it because one developer started up a 100 node cluster and left it on for a month. True story. By the way.
I have seen worse as well. So I've had a scenario where, without naming the customer, they actually had a 128 node cluster. Somebody physically manually went there and said, do not shut down automatically, because those are the things that are built in Snowflake. You would shut down a cluster if nobody's using it. He manually went there, unchecked that, left it running over the weekend, and it was not a good conversation after that.
Absolutely.
Yeah,
but that's the benefit, though. You could actually do that. Like, that's the key for me. And, when we talk about reimagining and really the compare and contrast for what we have seen previously, right?
Yes.
That wasn't even 4 years ago, 5 years ago. You couldn't get to that kind of scale, right? So to me, that when we talked about comparing and contrasting kind of why it's so great to be a data scientist, or really anyone in the cloud at this point, is that ability to have that at your fingertips.
Yeah.
So what are your thoughts there? And what are your thoughts, actually, everybody? Love to see your comments here on the LinkedIn. Follow us, of course, on YouTube, Facebook, or anywhere else where you're getting your podcasts. But please join the conversation. I'd love to hear, if anything, we love stories around here at the Proof of Concept podcast as well. So.
Yeah. And I think my 2 cents on the whole compute that we were talking about, like, again, data scientists themselves have actually now figured out that there is different kind of compute that they need. They need massive amount of compute for certain section of data science workload, typically training a model, running some kind of feature engineering that is very intensive, that requires a lot of RAM for that purposes. But then if you look at data processing, and when you look at inferencing, all of that can actually benefit from massively parallel processing, MPP kind of infrastructure under covers. So again, the fact that you can have a really large machine for a certain use case, and then a lot of tiny machines that can be used as a cluster to make your jobs run much faster, right? And all of them fall under this data science umbrella. That is probably the beauty of being in cloud today.
Yeah. No, and I think that's when I think about just even any sort of workload in any individual, when we're talking about even inside of data science, if we're talking about software development, comparing those across, right? This is all available. If you're writing, Rust, a Rust application to deploy into a Kubernetes cluster, that's not happening. A couple of years ago, your ability to scale out is not just a benefit to the data scientist, but it really has truly changed an entire paradigm in terms of how we work in general. So to me, that's one of the most interesting things going on about this. So let's talk a little bit about, we typically like to say, where's the value? So how can we make money, save money, or improve the customer experience? So I'm going to throw a couple of out at you. So when we talk about making money and revenue as a data scientist in the cloud right now, what do you see? How are customers, of Snowflake and general data scientists, how are they going about using this scale and capability to effectively move their businesses forward?
Yep. Again, great question, because I don't think it's a matter of why, but it's a matter of when for most organizations, and how for most organizations to start leveraging data science and machine learning.
Mhm.
Everybody knows that if they end up integrating machine learning and, for that matter, AI applications, and they, as part of their business itself, they're going to make substantial gains in the revenue.
Mhm.
So that is something that everybody knows about. In fact, I have customers that are now thinking about moving to cloud. In fact, I speak to people that are still on-prem, but they're making the
They're
technology
still out
decision.
there. They're
Oh,
still
yeah.
out there. Yeah,
And
yeah.
the amazing part here is that they probably don't even have a data scientist today, but they're making their technology decisions based on the
Mhm.
fact that they're going to be doing data science when they move to
Yeah.
cloud. So that
So
is, yeah,
Mhm.
that is very, very, that tells where the mindset is,
Mhm.
from the customer perspective. But the money that gets made, or how you monetize the data science or machine learning for an organization, comes from actually looking within
Mhm.
what
Inside of
organization.
ourselves, is it with us all along?
I mean, yeah, we're getting philosophical here, but I mean, that is true in that case as well. But I think for organizations, there was a very interesting conversation just a couple of days ago in our Sydney summit. One of the customers now, they were asking, like, how do I make sure I understand data science? I understand, using all these patterns and paradigms. Like, it's all good. Like, how do I make sure that this is benefiting my underlying revenue? And this is where I think it's a core problem. Like, unless you don't know what you are going to use data science for, right?
Mhm.
This is the first step. Every organization needs to know, this is what we want to do. This is, and again, there's no set outcome, and this is something that they need to be, first of all, they need to be aware of, right? It's not like BI, where you know that is the dashboard I want to see, so make this
Mhm.
happen. It's mostly an hypothesis. Somebody thinks that, this is probably gonna, if we can predict, or if we can somehow have our customers in a particular group or segment, then we can probably do our marketing better, which will probably have benefit in our revenue that we will generate, right? So there's a lot of ifs and buts and probably in that statement, but that is true. This is what data science really is when it starts as a project. And then they have to continuously, slowly start delivering on the benefits. So somebody needs to take a simple problem, do not overcomplicate it, right? That's
Mhm.
something that I tell everyone. Like, take something that is very, very simple, and take that and treat it as a project that you want to take it to production.
Mhm.
Because unless it goes to production, there's no value out of it.
Yeah.
So the
Well,
money
at
is going
least
to be made.
some, not nearly as much value. I'll say that. Definitely.
True, but yeah, unless you can't run it every day, right? That is
Yeah.
my thing. You can run it once in a while through your notebook that are on your laptop, which is fine, which may work for some organizations.
Mhm.
But unless you can run it once in a while, every day, in fact, on a
Is it
server.
part of your business? That to me
Yeah,
is always, you bring up a good point, and I when I'm talking to clients about this and they're early in their maturity journey, I always talk about Stephen Covey's second habit of highly effective people, which is begin with the end in mind.
yes,
So know what you're doing. Uh, you brought up the concept and idea that, hey, not a lot of folks are down that road. We just actually put out at Dataiku, we put out an IDC info brief, worked with them. This is the third time we've done so, and only 39% of organizations in APAC today are actually using AI.
Hmm.
And those that are starting to pivot in much the same way you're talking about. They're getting the value out of it, and that's what's bringing about these data scientists and the value that they can bring, because they're starting to look at more at the customer problems
yeah,
out there today. So personalization, optimization, uh, how do you improve that customer experience?
Absolutely. And again, because Forrester has done a study back in 2020, and back in the days, only two-thirds of the organizations are actually not going beyond experimentation phase on data science.
Mhm.
Less than 15% are actually running it on a daily basis as part of their business.
Mhm.
Everybody has to think with an end goal in mind. Like, how do I do something, like create a form factor, build a project or build a model, deploy it, run it on a daily basis, gain confidence, show the value, and then do it again, right? It has to be like a repetitive process that you're able to build early in life cycle. What you can't do is let's build 10 cool models and then we'll worry about productionizing them. So that's
But
not.
I want to build 10 cool models.
Yeah, and that's where the two-thirds of the projects are. They're all just
Yeah.
start building the models. The second
So,
aspect of it, and this is where
mhm.
I want to also start talking about things that for the future, right? What's going to happen?
Well, before you do that, before you
Okay.
start, because I want to stop you right there before you get into the predictions for the last segment. But one of the things we highlighted a little bit earlier, we all hear the horror stories, and this is the save money aspect. You know,
Yes.
So, what sort of governance are you seeing? What sort of processes, frameworks people are putting together to ensure that, hey, these sorts of things do not happen? Because, in effect, a bad experience very early on in a journey colors the rest of the journey itself. So, what are sort of what are the rules, the frameworks, the best practices people are putting in to ensure that they don't hurt themselves? And we'd love to hear what you guys think about this. It's like, how do you know, any stories, horror stories, but how do you actually, try to, stop that from happening? So please follow us on Facebook, drop comments here in the LinkedIn, and obviously anytime, anywhere, wherever you're getting podcasts. So what do you got, Rishu? What are you telling folks?
Yeah, look, again, the conversation is becoming more specific because the answer is depends on what they are using. Again, we have three major cloud providers globally. Most of the organizations across the globe are working with these three major cloud providers. There are specific organizations, and depending upon the product, like every good product would have some sort of safeguards built
Mhm.
into the product, right? Um, this is where it's very, very important to understand how the money is spent on whichever technology they're using. um, and again, this could be a completely different set of individuals and good organizations that I've seen. Again, without taking names, one of the best organizations I've seen here in
The guilty
Australia.
will remain nameless.
Yeah, look, again, I just don't want to take names.
Yeah, no worries, no worries.
Those guys are so good in predicting their spend. They do a lot of things. One thing they've done is they have individuals, because they're using certain products where it's not that easy to figure out, or there are no built-in safeguards against spend. They have individuals. Their job is to actually understand how the money is getting spent. Because, for example, let's take AWS as an example, right? um, People think storage is cheap. Storage is absolutely cheap, but having said that, they
What type of
charge you for
storage?
they charge you for accessing. Like, not many people realize how that bill can actually add up really, really quickly. um, there are obviously things built into the product that can predict, that can help you. It's important to understand, right? I think it goes back to the point where if you don't understand, the problem with cloud is it makes everything accessible, and it makes everything accessible so easy that you
Mhm.
can if you do not have the right kind of people watching, overlooking, understanding how these services are going to cost them, it's very, very easy to lose track of it. And this is where I really appreciate organizations product that bake this functionality into the product itself, right? So
Mhm.
it should be as easy as defining, let's say, budgets across your compute resources. Or you would basically go and say, hey, I'm using all these compute resources for my projects. I want to budget this project, and I'm not going to spend more than, or notify me if I'm
Mhm.
spending more than 50%
Yeah.
of this of the cost, right? It should go in that direction where it's self-managed and self kind of what's the best
Governed.
word? Governed, but I think self-monitored. Products needs to be built keeping this in mind, because I think that's going to be the biggest, as you said, that's going to be the biggest nightmare when people
Mhm.
are going, especially it's not comfortable for organizations when they're coming to cloud, but it can be very, very expensive once the organizations are in
Mhm.
cloud as well. So
Yeah.
this has to be built in.
Yeah, I love great follow on Twitter if you ever like to hear your snark is a guy by the name of Corey Quinn with the Duckbill Group. He has a couple of podcasts out there, and he talks a lot about this, transparency and costs. The cloud gives you that transparency, but depending upon what services inside of AWS you use, you may have a little bit more transparency in others. But the architecture itself and how you design your systems and applications ultimately is a factor of, will drive the cost and your posture and surface area of what you're dealing with. So I think that's great advice. Is you know use what you got. Don't go into any of these technologies without the concept and idea. Let's at least have the emergency brake or a safeguard in place, so at least I know if I'm flying down the road and I'm going 250 kilometers an hour in a 70, that,
Yeah.
whoops,
It never ends well.
it never ends well. That's right. But this is so following into our last discussion here, part of the proof of concept podcast. I'm going to ask you to put on your prediction cap, put on your magician's cap, and kind of what is the, and I'm going to give you a little prompt. I'd love to hear as well. Number one, what do you think is going, why will it continue to get better? What's new and exciting that will come down the pike for the data scientists that will continue to move? And also, since you're here and you're someone who's, we have a number of listeners who are just getting into this industry and getting into data science. What would you suggest in terms of any particular resources or knowledge bases, certifications that you see or could be incredibly helpful for folks?
Absolutely. So let's first tackle the second problem or the second question.
Mhm.
Anybody who's planning to get into data science space now, I would say, like, do not, the two things that happen, like now there's a reverse problem that I had. There's so many resources available there. There are
Mhm.
Coursera courses, there are Udemy courses.
Coursera, Udemy, YouTube
Oh,
videos.
exactly. YouTube. You search on YouTube, and it's very easy to get overwhelmed. So, my suggestion to everybody that asks me this question is that you pick one. Like, you cannot go wrong. Like, it's one of
Okay.
those, right? Pick one that has a structured way of telling you, or introducing you to data science, right?
Mhm.
It could be certification is something that you would want to do to self-validate how good you are, or what is the gap that you still need to go and learn. There are courses that actually take you through and teach you based on the certification exams as well. So, cloud providers have certifications.
Mhm.
You know, our organization
Present
has
company
certifications.
included for both of us.
Yeah, look, I mean, all these organizations. I'm just trying to not be very
Yeah.
specific around certain organization, but all I'm saying is, like, most organizations now have certifications for this practice. But the point here is, how do you get to a point where you're ready to take a certification exam? And my suggestion is, like, pick a course. Don't overthink this, right? Go to Udemy, go to Coursera, go to YouTube. Like, if you think this is the right course for you, do the course. Right? It would probably take you 3 to 4 weeks, maybe 3 to 4 months, depending upon how difficult or easy course you pick. Stick to it. Like, do not get distracted. Um, do the course from the T, and once you have done that, right? First of all, you have to do it. Second, like, stop taking more courses. Because this is one thing that everybody does. They're like, oh, we have done this course, I probably know what is regression, but let me do this another course and I'm going to learn more about classification, which the course would have taught, but they probably did not get a lot about it. The second thing that I always tell people is, another great resource, you have to go and start looking at code. Like, start
Mm.
getting
Mm.
like, do not overthink stuff. Go to Kaggle. Pick a data source, pick a problem. You want to learn more about classification? Go to Kaggle, just search for classification, and you would find data sources, you would find notebooks. Go and access those notebooks, open the notebook, download the notebook, like be you know
Be one with the notebook.
Be the thief, right? I would say be the thief, right? Because you're learning right now. What you have to do is understand every single line of code. Like, until you don't understand every single line of code in that notebook, do not pick the second one. And the more time you spend with the code, the more comfortable you get with reading the code, more you will realize that they're all the same. It's not too different. And end of the day, the concepts would start getting more clear in your head. And again, the more you read this course, do these notebooks, you will figure out, you know what, I kind of have this question. And once you have a question, then go and explore that one particular topic. Just don't go start hunting for things that you have no idea what it is.
That's a great way to attribute it. So what's going to happen? What do you see in your kind of view of, what are we going to look at in 2 and 3 years, and what's going to still be great about being a data scientist?
Yes, that's so. In my opinion, I think data science itself would keep getting easier from the perspective of getting access to resources, getting more access to data. In fact, if you see, the market is now, so data is core for anything that we have to do with data science. It's the starting point. What is happening in last few years is that getting access to first party was always easy, right? Mm-hmm. Getting access to your second party data, third party data is actually now becoming much, much easier. There are marketplaces out there that you can actually go in and get, with a single click, get access to data. You can build your own marketplace with select group of individuals, customers, second party providers, mm-hmm. and you can start sharing data, right? So once you have eliminated that data barrier, and you have access to compute resources, and you have ways to use your favorite algorithm, building a model. And as I said in the beginning, it's not about building the model. It's all about taking that model to production and running it on a daily basis. It keeps on getting easier and simpler. But I think the end game is not that. The end game is the benefit that businesses are going to get, and which is, again, going back to our initial discussion point around business benefits, is not building a model. Is not there's a bit of benefit when you run it on a daily basis in a batch mode, or you integrate an application for an online inference. The end of the day, your consumers, the business users, are the ones that they still do not get that leverage of the model that you have built. They can't interact with those models. It's very, very hard for them to do that. So in my opinion, applications built on AI, so AI applications built on data, is what is going to happen in the next 2 to 3 years time. Like, somehow, like, once you have built a model, how can you build an quick, easy AI application? Again, think about productionizing it first. How you can have an AI application that can run every day in the hands of a marketing analyst or a business user that can actually go and find out how, if I change my investments in different channels, how my revenue is going to be affected, right? The model that you have built can easily be used through an application. And that is, I think, going to change the way we can democratize data science for business audience. Because today there's a massive gap between business and data scientists. And the only point where they meet together is the inferences that are written back into databases, which are then accessed through a Tableau notebook.
That are in a meeting room where they're bickering back and forth at each other. One of the two.
Yes. So there's no interactivity that is happening between the business and data scientists. I think that barrier is still there, and there's a need to take that barrier down. And I think that is the next big thing that's going to happen in this space.
If I was to kind of put on my cap on this, number one, the same deal. The barriers continue to fall. The library, as someone is an R programmer by trade, in SQL, I'm a weird guy, just in general, versus everybody else. But I see it a lot. I see a lot of what has in R is becoming much more pervasive as a culture in the rest of the data science community, being, hey, let's wrap functions. Let's make things easier for people to go out and do what they need to do. I also see a lot more of the specialization. If we, I think if you went back 5 years ago, you would never even, the term data engineer or data engineering didn't even exist. The role did. It was part of a data scientist role, or maybe you were an ETL developer or a DBA, but the function was there. I see it continuing to follow along in much the same way as I make this analogy back to webmasters at the beginning of the late 90s, beginning of aughts. The webmaster was responsible for the server, the administration of the server, the content, and the development of the application itself. And guess what? Those all splintered into specialization roles, and we're going to continue to see that in the data scientists. The good news is the stuff that's really cool and very interesting to a lot of folks in data science in terms of building models, we're going to continue to see that specialization go through ML engineering. You see that much more often now than you did probably 3 to 4 years ago. So that specialization, I think, is going to be incredible for a lot of folks out there. I do want to make one more point that you made a little bit earlier, and we've kind of talked about, beginning with the end in mind, beginning with the production in mind. So earlier this week, Greg Root, the head of data platforms for Canva, was a guest right there at the Snowflake Summit here in Sydney. And that was one of his key takeaways. Like, you have to start, with some concept of getting something into production. You must have a view of that before you begin. And, given Canva's, how well they're done, not a bad way to kind of address the problem, right?
I loved his point of view where he was saying that treat this as an engineering problem, right? So you do not, like, whenever you're doing data science, like, it has to be an engineering problem. There has to be CI/CD built into your thought process while you're actually going and thinking about building a model. Think about productionization of that model, like before even you go and start playing with the tools and technologies. Again, as you said, like, Canva is, if Greg is saying that, and if they have 40 models in productionization and production, he knows what he's saying.
Yeah. And I think that's the benefit of the last kind of, what I think is great about being a data scientist right now, especially in the cloud, is you get to understand and learn from all of these individuals and organizations that have been scaling up, like Canva here in Australia. Just an incredible story for the country itself. But standing on the backs of giants is not a bad place to be in a lot of ways, because now you can actually, you don't have to start brand new. A lot of folks retread that I've gone down that road, and we'd love to hear how you've gone down that road, or how you might even be starting to go down that road. Maybe you're, as an organization, just haven't, maybe you're listening now and you're like, hey, maybe, should we be thinking about this AI stuff? Love to hear your comments. Love to hear your feedback. Rishu, it has been an absolute pleasure. As always, my friend, it seems like we always have a good time when we start chatting with each other. So we end up going a little bit longer than we should, but it's been fantastic. Thank you so much for joining.
Thank you for having me here. Thank you.
And thanks everybody for joining us here at the Proof of Con podcast. Take care. Thanks so much and have a great day.